Next, we have a talk with Alex. Alex, I believe you're going to be our final discussion today, right? And you have slides that you want to put up?
Yes, and hopefully a demo, but we'll see.
Demo. Okay, let's see.
Well, yeah, thank you guys so much for having me. Thank you, Adam. Excited to be closing out the conference. Thank you for all you guys who stayed. And my favorite part was definitely Demetrius dancing in the intermissions. It was quite awesome. So
take it away, Al.
Cool. So yeah, today I'm excited to talk about Zeno and more specifically, kind of an interesting take we have on evaluation. We had a bunch of interesting talks today on evaluation and all the challenges associated with it. So excited to add our own perspective here. Before we get into it, I want to shout out our awesome team. We're all researchers at MLOps. We have undergraduate students, graduate students, professors. We've all been contributing to this, everything from designers to ML engineers. So it's a really great team that I'm a part of. I want to just give a brief little overview of how we've been seeing the evaluation landscape today for LLMs and generative AI. So this might be a brief overview, but kind of the buckets that we've been seeing. One is the most classic AI evaluation or benchmarks. These are often large curated sets of data for a bunch of different tasks. And a recent trend we've seen is these kind of agglomerations of tasks, things like Helm or OpenAI evals, which basically combine potentially thousands of different tasks to try to test every possible aspect of how your particularly LLM is performing. What tends to happen more often in the real world is human evaluation. There often aren't big benchmark sets for the specific tasks that people have, like retrieval augmented generation. So a lot of people just depend on human feedback. This can be a developer just spot checking instances. Sometimes you'll ask your users to give you feedback, like a like or dislike. Or you might even ask users to do head-to-head comparison. There's an awesome project by the LLMs group on the chatbot arena where they had people pick between two different chatbot outputs. And lastly, an area that's been getting a lot of traction. I know the LangChain group's been working on this. There's a lot of cool stuff here on doing model-based evaluation. And I kind of split this into two groups. One is kind of the LLM data generation. And this is where you're actually just generating input data, like ask GPT-4 to ask a bunch of questions like a user would ask. And then the other side that people are testing out are actual metrics. So given that you have some input-output pairs, ask a bigger LLM, maybe GPT-4, to grade the output. You can grade it on things like fluency or factuality to try to kind of approximate an evaluation instead of a human. So those are three main buckets that we've seen of how people are approaching evaluation. And I'm not really going to dive into the details, but there are a ton of limitations and issues with these that people are trying to tackle. Classic ones for benchmarks is that they're not representative of real-world tasks. Sometimes there's data leakage, so people will train the models on the actual evaluation sets. This is happening a lot with the OpenLLM leaderboard that Hugging Face has, which has been interesting. And then for human feedback and model-based evaluation, these are often just very expensive and slow. For human feedback, you can't do model comparison. So if you have a bunch of feedback for one model and then you update that model, how can you compare? You have to put it back in the world and get more feedback. And then the classic model-based evaluation, the models, if you're using a evaluator model, the evaluator can also hallucinate or make mistakes, have all the same limitations that your base model has. So there are a ton of open questions designing these evaluation sets. But that's not really what I've about today, interestingly enough. I think there's this parallel side of evaluation that isn't as deeply explored. Given that you have some evaluation set, whether it's a benchmark or you gather a bunch of user data or generated it with LLMs, there is the actual results that you report and use to make decisions or to update your model. And across the board, almost always, the results of these models are reduced to a single metric or a single number. So we actually look at a lot of the most common leaderboards or evaluation results, everything from the LLM leaderboard I mentioned to the chatbot arena to Helm, papers with code. They will always almost report the results in a table with a single aggregate metric. Maybe they'll split it across a couple tasks, but that's almost everything that you get to look at. It's like, hey, this model is better because it has this number is a higher number than the number for the other models. But I want to kind of double down, and I think this is a very of understanding our model performance. And I want to kind of talk about this in one example of audio transcription. So say right now I'm talking and we were doing live transcription of my voice into text. We'd maybe be picking between a few models and looking at the average word error rate across a data set, how often it's getting the word transcribed correctly. But if you're actually creating a real product, you have a lot of other questions you probably want to answer. Does it work for non-English language if you're using the transcription model in different languages? Or if there's a lot of background noise or people are speaking very quietly. These are things that you really want to know. And as a product designer or a product engineer, you have to decide, hey, this model is much better for English speakers, but doesn't work for other languages. But given the demographic of my users, maybe that's okay. You need this information to make informed choices. And the simple takeaway here is that these single aggregate metrics, even if it's generated by an LLM, even if it's a bunch of human feedback, it's just insufficient. And I have a little analogy that I'm testing out here, see if it lands or works, is kind of teachers and students. When a teacher is trying to evaluate how well a student knows a subject, they'll give them an exam, have them fill it out, and they get the exam back. And they can actually look through the exam to see how the student maybe did reasoning or tried to solve a certain problem, or what types of questions the student's getting wrong, so they can tailor their teaching and improve their teaching. Developers do something similar with their LLMs. They'll give it example, look at maybe inputs and outputs. They'll give it a benchmark to try to understand the limitations of their model to either improve it or pick a different model. What happens though is we limit the information we get back by just having that single metric, that single value we get back. So instead of like having that whole exam back and looking at the specific questions or input data, we just look at this overall metric. That makes it very hard to actually decide in what ways our model is limited and what ways we might want to improve. So I think our hypothesis that we've been noodling on for a while now is that we really need better interfaces to unlock the insights in these evaluation sets. So there's a lot of rich data and information in the evaluation sets. That's often not the limitation. A lot of times it's actually the interface we have to make sense of that data. So that's what we've been trying to accomplish with the Zeno project. It's this open source AI evaluation platform we've been building over the past year. And it has kind of three core aspects, but the one that I really want to talk about and really what we think is a really promising direction are these interactive reports of analysis. So I'll give, hopefully this demo works. If you want to follow along, the two demos I'll be showing are live on our hub, so you can click around if you want to. So the first principle we have that we think is super important is actually looking at your data. So this is, if you go to the hub home, I'm looking at the audio transcription example. This is essentially the example I was just talking about. And this is what a typical Zeno project looks like. So here we're looking at a very interesting data set, a bunch of people saying the same exact phrase. What's interesting is there are people from all over the world with different experiences speaking English. So you could look through the data and listen to audio if you want. And here you see the label is all the same because it's the same base, but here we have the audio transcription output. In this case, we're comparing a bunch of the Whisper models, the OpenAI's state-of-the-art transcription models that a lot of people are using. So we're looking at some of the smaller models with some of the bigger, slower models, the base models. So we can start looking. It looks like some of these transcriptions are pretty good for the tiny model. Some are very odd, like transcribing in the wrong text, the wrong language. But what's more interesting is on the left-hand side here, we have all the metadata associated with our data set. So every instance has the speaker's age or when they learned English or where they're from. So we can kind of see these bars are colored by the word error rate. So we can clearly start to see some of these more nuanced patterns in our data. So we can see, for example, that our model has a much higher word error rate for speakers from Asia. So we could actually click and interactively filter our data versus speakers from, for example, North America. So you click on North America, and it would dynamically update and filter. And we could even cross-filter. So we could say, okay, what about speakers from North America who learned English later in life? And then we can see we have a much higher word error rate, 0.34, than average. So you can start kind of finding these intersectional insights of how your model's performing in this specific edge cases. Maybe that are just edge cases that you care about or use cases that you care about, or maybe complaints from users, etc. And we think that the magic here is that the only part that's really data specific is this instance view, this how we render the data. And Zeno makes it really easy to add your own instance views for specific data types. So we have a classic OpenAI API renderer for seeing chat conversations, including system messages. So this is looking at the conversations from insurance agents that you could do the same. So the filtering is the same. So we could look, say, at the chat context length. So looking at like very short conversations or conversations that are very early on, or any type of ablation or test that you want to do. We have other crazy ones. This is looking at 2 million prompt image pairs from Stable Diffusion. So here we don't have a metric that we can really look at as the quality of the image, but we can do some interesting analysis like calculating the average not safe for work level of the images. And we can start seeing patterns like images that with the prompt generated by the prompt that has the word girl in it have a much higher not safe for work level than those that have boy. So this is a very interesting insight and potential biases in your data, where there might be more implicit biases of the types of images that are generated for prompts with girl than boy, which might be interesting. Lastly, we have other crazy ones like looking at, this is IMU sensor data from iPhones. We don't have a model associated with it, but we could look at what does it look like to jog versus what does it look like for someone sitting. Start getting some idea of what the sensor data looks like. So that's kind of the first key principle we have that kind of Zeno lets you do is look at your data, specifically look at the model outputs, start getting a qualitative sense of how your model's performing. I think this is something that's super important to actually develop high-performing models that actually work well for your downstream tests. Kind of the next principle that we look at that is super important is actually quantifying these behaviors. It's not enough to just get one-off insights of how your model's doing. You really want to come up with reproducible tests of your model's behavior and model performance. So we can go back here. Let's look at this other example that we have, this GPT empty benchmark. And this is looking at a bunch of different translation models, specifically comparing kind of state-of-the-art translation with kind of these LLM-based translation models. We can do the same. We can look at how the models are performing across different languages. But maybe we see that, hey, our model's doing really well for French. And we want to compare specifically how our model is doing French versus, say, Romanian. So we could actually create a specific slice for this and be like, hey, language French. You could create any intersectional group you want, like French speaker or language equals French, where the text is very short if you wanted to, and create a specific slice. So now we could compare, say, language French across different models, like GPT-4 versus ChatGPT. And we see the accuracy is slightly higher. So it's a little annoying to have to go back and forth and change what model you're looking at, maybe change what metric you're looking at across these things. So this is where our chart creation feature comes in. We think it's super important to actually create these interactive visualizations that let you quantify these complex behaviors. So we can go in and we have some very simple charts like bar charts. Here we're looking at the overall performance across different systems for all your instances. And you could create different types of charts if you wanted to. You could look at different slices of your data. So how do we do for all instances versus short label instances? Looks like it's about the same pattern. Nothing that different, but you can start kind of interactively changing. Let's not look at the state of the art and let's only look at GPT-3 or GPT-4. And the charts, the same as with the other features, doesn't depend on the data. You can create any slice you want, create kind of any visualization you want. We have another interesting one that I like is looking at this spider or radar chart that have gotten kind of popular with looking at LLMs across a bunch of these dimensions. And this is actually looking at the script of the language. It's like Latin script versus Georgian script. What's really interesting here is for some reason, Cyrillic script, all the models do the same. No idea why. We talked to some of the people running these analyses that are more familiar with linguistics. They also didn't know. So a lot of interesting behaviors that you can start exploring and start thinking about. Cool. So that's kind of the next step is look at your data, start quantifying these behaviors so you can actually do formal comparison between models. And lastly is telling stories. And this is something that we've been thinking about more recently, is how do you actually just make sense of all the ways in which your models can perform? It's very hard. There are just so many dimensions of quality. It depends on your users, on your use case, on what they're using it for. And there's a really rich history of kind of interactive data storytelling from the world, just the kind of data visualization and data analysis. You've probably seen some of the New York Times' upshot articles that are interactive, that have simulations. You might have seen DistillPub that was unfortunately discontinued, but it has some awesome explainables on machine learning, or Our World in Data is a really popular one creating visualization. So we took inspiration from this, and I've been thinking about how we can tell stories about how our models are performing. So what we have is our arc of reports that you can create that are grounded directly in your data and in your model performance. So here we created a report about these translation models, have some markdown, some description of the model, but then we actually have the charts that are directly pulled from our project. So we can go straight from just the raw data, raw input, to these nice interactive charts, to these interactive reports that we can share. So this actually, before it was talking about the overall performance and only had the all instances, but this actually went and edited that chart, it live updated in the room. So we can dive deep and start understanding why are LLMs worse than state-of-the-art translation models. Turns out a lot of times they have a lot of repetitions. So we could actually go back and we can actually look at the data specifically at repetitions. So there are a ton of instances where we see these hallucinations that we can actually quantify and formalize into a slice and do analysis across. So we have a bunch of charts here. Some of the ones I mentioned before, like the radar chart, we can just plop directly in here. The idea is we're working actively on making these very reproducible. So if you had a new translation model that you thought was state-of-the-art, ideally with just a couple commands, you could upload that new model, and it would update all your reports dynamically. We have another one here. We have a B-Swarm chart looking at all the languages, so you can kind of explore languages where maybe there's actually better than the state-of-the-art translation model. We find a couple interesting ones. This Tok-Pisin language is a Creole language that's based in English and Latin script. So there's some hypothesis that GPT-4 is really good at inferring or understanding kind of English-like or Latin-like text, and is actually better than maybe the state-of-the-art language models that hasn't been exposed to that much of this language. So you can really start getting that kind of more granular view of how your models are doing. We have another one on the auto transcription that you can also explore. So that's more or less what I want to talk about today. Is I really think that people should be diving deep into these benchmarks, into all this rich data they're collecting of how their models perform it, and really create these narratives that really dive into how their models are actually performing beyond just a single aggregate. There's a lot of interesting directions to go in, a lot of open questions. One that I kind of glossed over, that's the whole point at the beginning of the talk, was actually building these evaluation sets is very hard. How do you create benchmarks? How do you effectively gather end user data that you can then do this analysis across? There's another point of error discovery. There's 1,000 different slices and ways you could slice and dice your data to find interesting patterns. That's very hard. Can we help people automatically discover these areas of data with high error, highlight interesting differences between models? And lastly, can we actually kind of move from storytelling to testing? Once you start identifying the interesting areas in which you care about your model performance, can you encode that also as a specific test? There are a lot of interesting talks earlier today about how people are thinking about regression testing and evaluation. Kind of what does it look like to have CI/CD for a model is a very open question that people are actively thinking about. And it's a very exciting time for this.
Alex, thank you very much. We had one question here. Maybe I could get that out of the way very quickly. If somebody wants to make sure that they're on stage one, they can move ahead. What about label-free evaluations?
It's a great question. We have thought about that, and there are some metrics that you can do model-graded evaluation where you just, given the output, you ask the LLM to give it some metric, and you can do analysis across that in Zeno using that as a metric. What we have found is that it's better to have labels. If anything, you might as well just use the LLM to generate labels and have a small set of labeled data. That usually gives you a much stronger signal than doing label-free evaluation. So we have explored that. It is an active area, but I think what we found across a bunch of different use cases is it's better to spend either some time with small data or even just use an LLM to generate the labels and then do evaluation. But Zeno doesn't care. If you want to do without labels, you can go for it.
However you get it. Yeah. I'm extremely bullish on this direction.
I'm glad to hear it.
This is fascinating. I had interviewed about a year and a half ago somebody, Professor Jose Hernando Diaz, and about this, like, aggregationist perspective of machine learning evaluation. And I think either he or I don't remember the course of the conversation, we called it practically a scandal that we're looking at. It's such a like multifaceted and highly dimensional concept, this performance, right? Like when you evaluate the performance of a human being, you never just aggregate it like this. Okay, this is their score. I guess maybe you do for certain behaviors, like, I don't know, your credit score or something, right? But it just ends up hiding way more than it reveals. And I think like one other example is like what happens, let's imagine you have like a self-driving car and it's 99.99% accurate, whatever. If you want to bring it up arbitrarily high, you just keep serving it very simple examples. That's all you have to do. But with a platform like Zeno, it feels like this is almost like an automated, error analysis on steroids. Something, you know what I mean? Like,
yeah. I think at the simplest, it's like you can just get so much by just looking at your data. Like if you just let people like do some sort of structured way of exploring your data in a systematic way, just everything comes at you like, wow. But I totally agree. I did the analogy of like, you wouldn't hire someone based off their IQ test. And that's how we're picking LLMs. Like, no, you actually want to know how well they're going to do the job. And you got to like dig in and understand all the dimensions of that job. So yeah, totally agree.
Thank you very much. I also think this is, it's a piece with, I believe, like what the spirit of the ending of this conference should be, which is a lot of people have showcased and displayed and shared with us like best practices and things that they've done. But ultimately, I believe a conference like this should not be about giving solutions, but inspiring us to all the questions that are still open that need to be dealt with. I mean, this is such a young space, and I imagine we don't even have the right abstractions, the right terminology and language to talk about most of these things yet. And it's struggling to be born, but ultimately it will be, and it will be because of people like you doing the work and people like the audience tuning in. Alex, thank you very much.
Very exciting time. Thank you so much, Adam.